Hey everybody, Mr. Morrell here, and we're going to talk about homework assignment 7.5, geometric sequences, explicit functions. What does that even mean? What that means is, well, we've talked about ways to write recursive functions for these geometric sequences, and that's cool, but what if we don't know the numbers before it? Like, what if you have a geometric sequence and you want to know what the 20th number is or something like that? We need some kind of an explicit function. Just so you know, those of you curious where in the crap are we going to use this in real life, this is a lot of what people do for like carbon dating and things like that. If you talked about that in your science class, anything with a half-life, that's a big exponential function. And also, not only that, loans and things like that, anything that uses interest rates, that kind of stuff is exponential functions, or geometric sequences with explicit functions. So that's kind of cool that we're using some pretty practical stuff right now. So yeah, why don't we just go ahead and jump in? So the whole point of what I'm saying is, what am I saying? I'm saying that our function's going to look different than the linear ones did. Like, we've been so used to blank x plus blank, and it's not going to be that way very much longer. Well, yeah, not very often. So we're going to have a new kind of function, and I'm going to talk you through it. So, to help us with this new weird-looking function, we're going to talk about these questions. Sorry, I'm kind of distracted. It's the day after the Paris attack, so I have the news on in the background, so you can see how long ago I made this video. And so stuff keeps unfolding, and that's why I'm kind of distracted. But I should just be a teacher. Okay, so here we go. What is the first term in the sequence above? Awesome, it's a 6. We knew that. What would the term before the first term be? Well, to figure out what that number is going to be, I'm going to have to know what the pattern is. Oops. How am I moving from one number to the next? Well, it looks like to go from 6 to 12, that's either timesing by 2 or adding by 6. To go to 12 to 24, that's timesing by 2 and adding by 12. So, it seems to me like we're multiplying by 2. So if I'm multiplying by 2 to move this direction, I need to divide by 2 to go this direction. So the 0th number in this case would be a 3. What is the constant ratio of the sequence above? Well, we just barely talked about how it's a 2. We're multiplying by 2 every time. So the recursive function is pretty easy. We know that the first number is 6, and to get a new number, that's going to equal the number before it times by 2. The way that we write the explicit function, it's no longer blank x plus blank. Now it's going to be blank times blank to the x power. So the first blank is going to be our 0th number, which is kind of weird because we're used to blank x plus blank, where this was the 0th number and that was the constant difference. But notice here we're going to have a 0th number times our constant ratio to the x power. So the 0th number is going to be a 3. And then we're multiplying by 2 every time. Okay? So we just got to practice with that, really, is what I think it is. I'll practice with you. We'll be friends and stuff. So here we go on question 6. Well, the 0th number. Okay, well, to get the 0th number, I need to know what the ratio is. Well, the ratio to me looks kind of obvious here. We're multiplying by 2. So that's going to be the number that goes with the x. The pattern always goes with the x. Then the 0th number, well, if I'm multiplying by 2 to move to the right, that means I need to divide by 2 to go to the left. 2 divided by 2 is a 1. So a 1 is going to go right there, and a 1 is going to go right there. And just information for those of you that are super advanced, 1 times 2 to the x is the exact same as 2 to the x power. You could write it either way, but we'll just try to keep it like this to keep it simple for these level 2 questions. Alright, question 8. Well, probably easier to find the constant ratio first, to go from 3 to 9 to 27. It looks like we're multiplying by 3. Again, if you didn't know that, you could pick any number and divide it by the number before it. So if you typed in your calculator 81 divided by 27, it would tell you 3. And then, let's see, 3 divided by 3 is going to be a 1. So that would be 1 times 3 to the x power, which, again, if you cared, it would just be 3 to the x power. We could simplify it that way. But I don't want to get too complicated here for you all. Alright, let me go ahead and slide up. Question 10. Ooh, this one's getting trickier. How do I go from 1 to negative 5, or negative 1 to negative 5, negative 5 to negative... Well, let me pull out my calculator. Negative 25 divided by negative 5 is a positive 5. We're multiplying by a positive 5 every time. And so, this is going to get a little tricky here. Why don't I go ahead and set up my blanks? F of x equals blank times blank to the x power. So I know a 5 is going to go right here. And I know this number. To get that number, I'm going to do negative 1 divided by 5 in my calculator. And if you want to, that'll give you a decimal that you turn back into a fraction. It'll be negative 1/5. Or maybe you'll just remember that we would take your negative 1 and divide it by 5. And one way we could write that is as a fraction. And so that's actually our 0th number. Negative 1/5 times 5 to the x power is your explicit function there. So that's pretty fun. Alright, let's go on to, we'll do question 12. Okay, question 12. To go from 5 to 10, 10 to 20 and stuff. Looks like we're multiplying by 2. Okay, so here I need to do a recursive function and an explicit one. Well, recursive is really easy. The first number in the sequence is 5. To get a new number in the sequence, I need to look at the number before it and multiply it by 2. If you don't know how I did that, just go watch my last video. Then, my explicit function is going to be f of x equals blank times blank to the x power. I know that my constant ratio is a 2. We're multiplying by 2 every time. Now I need to find my 0th number, in which I would just take 5 divided by 2. And hey, look, there's my 0th number right there, 5 halves. And 5 halves times 2 to the x power is the answer I'm looking for. Now I just want to take a second and confirm that with you guys. If you want to pull out your calculator, remember the explicit function says, hey, I could plug in a position number for my x value, and that's going to tell me what the term is. So for here, that's the 5th number in the sequence. So in my calculator, if I type parentheses 5 divided by 2, 5 divided by 2 times 2 to the 5th power, you can go ahead and do that, and when you do, it's going to tell you 80, which is awesome because that's what we were hoping to get. Okay. Alright, now let's talk about level 3. Level 3 is just going to be a little bit trickly because it's going to look like we're dividing. But remember, we don't divide in sequences. We multiply by weird numbers. So let me just help you with question 14, I think. Because as long as you've got your calculator with you, and any calculator will do, you don't just have to have a fancy graphing calculator. You can use any calculator. But if I take 32 and divide it by 128 in my calculator, it's going to give you a crazy fraction. And you can have the calculator turn the fraction into a decimal. And you're going to see that the constant ratio is 1/4. So the first number in this sequence is 512. To get the new number in the sequence, we want to look at the number before it and multiply it by 1/4. So our explicit function f of x is going to equal blank times blank to the x power. I know that 1/4 is going to go here, and something we talked about in class is how if your fraction, if your constant ratio isn't a whole positive number, you need to use parentheses around it. Now we need to find our 0th number. So I'm going to take 512 and divide it by 1/4 in my calculator. Let me go ahead and do that. And I got 2,048. So that's our 0th number, 2,048. And it would always be worth checking. Here's the 4th number in the sequence. So if you type in your calculator 2,048 times by 1/4 in parentheses to the 4th power, push enter and it should tell you 8. And mine does. So that means that I'm the bomb.com. Okay, so again, I think you can do that. I know these numbers get ugly and weird, but that's why you're using a calculator, because a calculator will do all of the tough work for you that you don't want to do. So make sure you're using that calculator and getting the right things and making sure you're typing your parentheses and all of that stuff, and you'll be in good shape. I'm not that worried about it. All right, I hope you guys have such a great day. I will talk to you later.